So this page here is how we're going to start connecting this idea of a graph to standard position circles and also formulas. So in the previous unit, we talked about how when we undo sine functions, we end up with theta 1. There's two possible angles, so theta 1 and theta 2 that show up. Okay, in a circle, when we talk about a sine value, we say a sine value is the y position. When I talk about sine value, well, I can have a sine value that has a position there, but I also have an equivalent sine value here. And there was theta 1, and there's theta 2. Okay? So they both have the same y position. Well, the same thing shows up here. Okay, so if I have this a sine value, okay, in this case, we can say, let's say the sine value is 0.5. There's an angle in quadrant 1 that represents that will give us that sine value, but there's also an equivalent angle, a different position, but an equivalent sine value in quadrant 2. So that we see it like this in standard position, we see it like this in the trig function. And we had that formula from that we use as well when we calculate theta 2. We just say, well, if theta 1 is this angle here, we can just go backwards the same amount or from pi. So we start at pi and we go backwards minus theta 1. And there's a formula. Pi minus theta 1 is equal to theta, the same sine value gives us theta 1 and pi minus theta 1 give us the same sine value. Okay? So there's our connection here. We have our standard position, we have our trig function, and we have our what we call an identity here. So we can show that in that way. For cosine, it showed up a little bit different because the symmetry is a little bit different. Here we have the theta 2 formula was 2 pi minus theta 1. Okay, there's two angles that gives us the exact same cosine value. So if we take a look at the symmetry of cosine, the cosine is x. So if we have theta 1 here in quadrant 1, we have an equivalent x coordinate down here. Okay, and that is going backwards theta 1, and that will give us the same x coordinates. So our formula we generated was if we start at the 0 and go forwards theta 1, we can start at 2 pi and go backwards theta 1 and get the same cosine value or same x position. Remember, cosine is the x position. So it shows up like this on the cosine graph. So here's our cosine function. If we have a cosine value here, again, let's say for sake of argument that this value is 1/2. Well, there is an angle in quadrant 1 that gives us that cosine value. But there's also an angle in quadrant 4 that gives us an equivalent cosine value here. Okay? And the symmetry is, well, we go forwards theta 1 this way. We start at 2 pi. We start at 2 pi here. And we can go backwards the exact same amount, which is what our formula shows us here. 2 pi minus theta 1. We see this as going in this direction and this direction on the circle function, or on the standard position circle. And we can see that same symmetry showing up backwards from 2 pi and forwards from 0 in the function. Okay, so this is our connection, how we can start thinking of these ideas of this theta 1, theta 2 issue in terms of a standard position, identity, and function. They are connected.